Okay, hello guys. Um, so today I'm going to record the video and give you the notes for section 2.2 and 2.3. I'm sorry, 10.2 and 10.3. Okay, so let's start with section 10.2. 10.2, it's about solving linear equations. Okay. And you guys have a PowerPoint attached from section 10.2. So I'm not going to copy the definitions and all the steps because you have 10.2 solving linear equation PowerPoint. I really want to focus on give you the example how to solve linear equation. Okay, so what we're going to do, we're going to solve equation with multiple steps using distributive property and combining like terms and inverse property. So before we do that, I want to review how to simplify using distributive property. Okay, so distributive property, let's talk about it. Okay, so distributive property, the formula is A times, in parentheses, you have B plus C. So what we're going to do, this is the same as A times B plus A times C. Okay? And the same will work if you have a minus. Let's say you have A times B minus C. You also can use the distributive property. So you multiply A by B. So this is the same as A times B minus A times C. So this is what we're going to use. So let's do some of the examples. So example one will show you how to use the distributive property. So let's evaluate, I will say simplify. And we have negative 3 times x plus 5. So we can use the distributive property. We'll multiply negative 3 by x. So this is negative 3x. And then what we're going to do, we're going to multiply negative 3 by 5. And that will give you negative 3x minus 15. Okay, so that's the final answer. Example 2. We have negative 7 times 2a minus 4. So what we're going to do, first of all, 2a you treat as a one expression, and of course 4 is the second expression. So we're going to multiply negative 7 by 2a and negative 7 by negative 4. Because when you have a whole number, you always take the sign which is in front of the whole number. So when we simplify, we have negative 7 times 2a minus, which is the same as plus negative 7, times, and again, don't forget that actually here, I should put in that square negative 4. So you multiply negative 7 by negative 4. Okay, so you take the sign which is in front of the number. And now we're going to simplify. So we have negative 7 times 2, which is negative 14. And we attach that a, because it's a multiplication between them. Negative 7 times negative 4, that will give you positive 28. Okay, so this is how we apply distributive property. I know students usually feel very comfortable with that. So let's move on and let's review how to simplify expressions by combining like terms. So what we're doing right now, we're just reviewing. so everybody will feel comfortable. And we're going to review how to simplify using combining like terms. Like terms. So let's talk about like terms. Like terms are expression which looks very similar, which what that means, they have the same variable. And if we're talking about variables of exponents, those exponents has to match. So that's like terms. Like terms must have the same variable. So let me just write this down. Okay. Like terms must have the same variables. Variables, that's our letters in equations or expression, and the same powers, which means the same exponents on the letters. Okay, so what we're going to do, we're going to combine like terms by adding, subtracting coefficients. So combine like terms, combining like terms means adding or subtracting the coefficients. The coefficients are the numbers, of course, in front of the variables. And again, that can be, for some of you, very basic, but also I do understand that some of us have a huge gap. Since last time when you took mathematics, I really sometimes maybe go too details, but I want to make sure that when I'm saying coefficient, everybody knows that that's what coefficient means. Okay, so let's do the example. So let's do example 1, and we have 3x plus 5 minus 7x plus 9, and we need to simplify that by combining like terms. So like terms, it's going to be the one which have the same variable, which will be 3x and negative 7x. And I'm going to combine them together. Okay. So how we're going to do it? In parentheses, I'm adding the coefficients or subtract. In this case, I'm going to subtract because I have 3 and negative 7. So this is the same as 3 minus 7. And I attach my variable, which is x. And also, the like terms will be, of course, the whole numbers. So I have positive 5 and positive 9. We're just going to add them together because they both positive. So then I have plus 5 plus 9. And if you want to, you can put the parenthesis, okay? It's not really necessary. So let's simplify. So we have 3 minus 7, which is negative 4x plus 14. Okay? And let's do one more. Combining like terms. So example 2, we have 3 minus 6y minus 7 minus 9y. So we need to simplify that. Again, don't forget that here I'm not solving any equation. I'm just simplifying expressions, okay? To have the equation, you should have a number on the right side. So let me identify the like terms. So like terms will be 3, it's positive 3, and negative 7. So I'm going to combine them. So I have 3 minus 7. Again, at the beginning, I will just put everything in the parenthesis. plus, and I'm going to combine the other like terms, which is again, you have 6y, but don't forget that you take the sign which is in front of it. So you have negative 6y and negative 9y. So to be on the safe side, you always can put parentheses, and we're going to add coefficients or subtract coefficients. In this case, I have negative 6 minus 9, since they both negative, and I'm putting y outside. Okay, and that will give us negative 4. And here, look what happened. You have plus negative 6 minus 9, since both are negative, that will give you plus negative 15y. And when you have plus and minus, of course, you keep only minus. So this is negative 4 minus 15y. And that's our final answer. Okay, so that was just a review on how to simplify the expression. And next, what we're going to do, we're going to solve linear equations. Okay. So next, we're going to talk about steps for solving linear equations. Okay, the detailed steps, you guys have it on PowerPoint. I just quickly going to write the shortcut of that. So step number 1 will be remove any parentheses. So remove parentheses. And of course, combine like terms. Okay, the second step will be clear any fractions. So I'm going to rewrite that, what you have on the PowerPoint, clear any fractions. And that's important because students don't like fractions. By multiplying all terms, which I always saying multiply both sides, all terms on both sides. By LCD. LCD means least common denominator. We're going to do problems like this. Common denominators. Denominator. Least common denominator, using simple language, that means a number which can divide each denominator which you see in the equation. Step number 3, group like terms on each side of the equations. I will skip that. Let's make that isolate the x terms. So I will just say it that way. Isolate the x term. I'm calling that x term because usually your variable is x, but technically that means isolate the variable on one side of the equation. By adding or subtracting. Okay, so I'm using the shortcut. So what that means, isolate the x terms, that means we keep the variable usually on the left side and moving everything else to the other side. Then the next step will be divide both sides of equation by the coefficient of the variable to solve for x. or any different variable. I'm just going to keep x. And number 5 will be check the solution. Check the solution, you will end up with the number, which is the solution of the equation. You want to just plug it in, make sure that everything works. So check the solution by substitute your answer into our original equation. Okay, so now when we have all the steps, let's solve equations. Okay, so let's work on solving equations. Okay. So what we're going to do next, we're going to do examples, solve each equation. Okay, so the first one which I'm going to solve it's going to be 3x plus 2 times 2x minus 1 equal 33. Okay, so first what I'm going to do, I have to remove the parenthesis, so we will use the distributive property. Okay, so we're having 3x plus 2 times 2x plus 2 times negative 1. So I multiply 2 by 2x and 2 by negative 1 equal 33. Okay, so let's simplify. So we have 3x plus 4x minus 2 equal 33. So now when I don't have parentheses, next what you're going to do, you're going to combine like terms. So we have 3x and we have positive 4x. So let's combine them. So that will give you 3x plus 4x, which is 7x, minus 2 equal 33. Next, what you want to do, you want to isolate your variable, which is x. So we have negative 2 on the left side. And what we want to do, we want to move that negative 2 to the right side because that's where you keep the numbers. So to be able to move number to the other side, you always use the opposite. You see negative 2, that means we need to add positive 2. Okay, that calls inverse property. So now negative 2 plus 2 is 0. So that cancel and we end up with 7x equal 33 plus 2, which is 35. And the last step, you want to isolate the variable, which is x. So you're going to use here inverse property. The opposite of multiplication is division, so we're going to divide both sides by 7 because we want to isolate x. So divide both sides by 7. 7 divided by 7 is 1x. So we have x equal, and 35 divided by 7, we end up with 5. So this is the answer. This is the solution of the equation. And we're just going to do that once, but let's check if that's correct. I would skip that. You guys can check that at home. But to check, you should go back to original equation. Then you're going to replace x with 5 and check if your equation is true. So I always mentioning to students that if you have on a test enough time to check your work, I will do it. But usually we're skipping that checking. Okay, so hopefully all the problems you guys solve correctly. Let's do solve different example. So let's solve example 2. We're going to solve the equation. So we have 3 times parenthesis x minus 2 plus 4x equal 8. So step number 1, I need to remove the parentheses. Like you see, we can use the distributive property. Okay. So we're going to apply that distributive property. So I multiply 3 times x, that will give me 3x, and I multiply 3 times negative 2, so 3 times negative 2, that will give you negative 6. And then I copy the rest, plus 4x equal 8. Now, when you don't have parentheses, you're going to combine like terms. So next, we're going to combine like terms. So like terms are 3x and positive 4x. Okay, so let's combine them. 3x plus 4x, you add in coefficient 3 plus 4, that will give you 7x. And we also have like terms, which is negative 6. I'm sorry, they're not like terms. Okay, so we only have, that's it. So we have 7x, I copy that negative 6 equal 8. Okay, so when we have that, what we're going to do, we're going to isolate 7x. Isolate 7x, which means leave 7x on the left side and move negative 6 to the right side. So to move number to the other side, you're always using the opposite. And opposite of negative 6, it's positive 6. So we're adding 6 to both sides of the equation. And the idea is that here you'll get 0. Negative 6 plus 6, of course, is 0. So we end up with 7x equal x 8 plus 6, which is 14. And the last step will be divide both sides by 7. Divide both sides by 7. So we're dividing each by 7, and we end up with x equal 2. And this is our solution. Okay? And of course, you can always check by substitution, but by replacing in your original equation x with 2 and check if that will give you 8. Okay, so let's solve more complicated problems. Okay, let's see. I will solve one more, and then maybe we'll solve one with and I think we'll be able to move on to different type of the equation. So let's just do one more. Example 3. Let's practice solving. So we have negative 4y minus 5 minus 4. And I like this one as a practice because it has a lot of negatives. Plus 8 equal 3. Okay. So step number 1, you need to remove the parentheses. And to be able to remove the parentheses, you're going to use the distributive property. You're going to multiply negative 4 by negative 2y and negative 4 by negative 3. Okay, so we're going to use the distributive property first. Okay, so let's do it. So I have negative 4y, okay, minus 5. And then I have negative 4 times negative 2. That will give you positive 8y, because y, it's attached to negative 2. And then you have negative 4 times negative 3. That will give you positive 12. So 2 negatives gives you positive. And I'm copying the rest. The rest is plus 8 equal 3. So let me copy this. Plus 8 equal 3. So now, when we don't have parentheses, next what we're going to do, combine like terms. So simplify both sides of the equation. So like terms, I have negative 4y, I have positive 8y. They definitely like terms because they have the same variable. And let's combine them. So that will give you negative 4 plus 8. Again, the sign of the number tell me if I'm adding or subtracting. So negative 4 plus 8, it's positive 4. And your variable, it's y. And then I have more like terms. Negative 5, positive 12, and positive 8. So here I'm just working from left to right. So I have negative 5 plus 12. That will give you 7 plus 8. That will give us 15. And of course, that's equal to 3. Next, what we're going to do after combining like terms, we're going to isolate for y, because you want to solve equation for y. So you see positive 15, that means that positive 15 needs to be moved to the other side. So use the opposite of positive 15, which is negative 15. So we're subtracting negative 15 from both sides of the equation. Here we're getting 0. So we have 4y, it's equal to 3 minus 15, which is negative 12. And the last step will be divide all by 4, because we're using the inverse property. Opposite of multiplications, it's division. That's why we're dividing each by 4. And that will give us y equal negative 3. So this is the solution. Okay, so we solved couple problems. There's one more example on the PowerPoint which you guys can follow. Also shows you the solution. Next, what I want to do, I want to go back a little bit to the definitions, and I want to talk about conditional equations, contradiction, and identities. So here, let's talk about conditional equations. So that can be new. Conditional equations. Okay, so conditional equations, that's equation that is true for some values of the variable but false for the other values. So let me write this down and give you the example. Conditional equations are equations that are true for some values of the variable but false for other values. Okay, so example, conditional equations, that's the equation which actually we just solved before. Okay, you're solving the equation and you end up with the one answer. So that's going to be conditional equation. So example, we have x plus 4 equals 6. You're going to solve this equation for x. So of course here you will subtract 4 from both sides and you're getting x equal to. Okay, so this is conditional equation because this equation will be true only if x is equal to. Okay, so this equation is true only if the condition, so the condition is that x is equal 2. Okay, why this is true? I'm going to substitute x with 2. So we have 2 plus 4 equals 6. And this is definitely a true statement. So what we solve again, it's everything before it was conditional equation. This equation, it's not true for different variable. So example, if I want to make x equal 3, okay, so that statement won't be true because if I will substitute 3 into my original equation, I'm getting 3 plus 4 equals 6. This is not true. So if x equal 3, the statement is just the equation in mathematics. It's not true. Okay, so conditional equation, you're solving your regular equations and you end up with one solution. Of course, in quadratics, it will be two solutions, okay, most of the time. Now, let's talk about the second definition, which is contradictions. You guys need to know what are the contradictions. So, contradictions are equation that has no solutions. Are equations that have no solution. And again, I will give you the example. X plus 1 should be equal to x plus 2. Okay, this is not true. This equation has no solution because, again, if I would do work, so if I would like to bring this x to the left side, since it's positive x, so I will use the opposite. I will subtract x's from both sides. This one will cancel, and I will end up with 1 equal 2, which is not true. If you're solving equations and your variables are cancelled and you end up with something which is not true, that's contradiction. Okay, so that means this equation has no solution. So we can say that this equation has no solution, or we can say that the solution is empty set. The solution is the empty set. Empty set is nothing. So most of the book using the notation for empty set like a 0 with the line like this, okay? Or some books using for empty set like a parentheses, fancy parentheses without any numbers or variables inside. I believe that Alex using this one for empty set. And the last one, it's going to be identities. Identities, we're also going to see that a lot, are equations. You know what, I really don't like to keep that as a plural. Is equation that has all real numbers as its solution. So what that means, whatever you're plugging in for x, any number, your equation always will be true. How you going to solve that you have? How you going to know that you have identity? You're trying to solve the equation. Your variables will cancel, and you will end up with, let's say, 5 equal 5, 3 equal 3. So you'll end up with the the same numbers of both sides of the equation. Okay, so let me give you the example of identity. X plus 4 is the same as x plus 4. Of course, this is identity because we have the same expression of both sides, but if you would like to try to solve for x, so let's say if we would like to move that x to the left side, since it's positive, you subtract x from both sides, that will cancel, and you will end up with 4 equal 4, so this is definitely true. So that's how you're going to know that you have identities. Not all the time. Sometimes you don't know that you have identity because your left and right side of the equation looks very complicated, and then you just need to simplify. And when you will simplify, you will see that your left side and right side looks the same. Okay. So next, what I want to do, I want to do one example. So this video will be only from section 10.2 because I don't like to record the videos which are over 1 hour because it takes forever to download. So that will be just the first video will be only from section 10.2. So this is our last example. We're going to identify. So example, identify conditional equations, contradictions, and identities. Okay, so we have A, B, C. A, we have 4k minus 5 equal 2 times 2k minus 3 plus 1. So you need to tell me if this is conditional equation, that means you're getting that one solution, let's say k equal to a number. If this is contradiction, which means you're getting not true statement, something what is false, or identity, your variables will cancel, and you end up with a true statement. Okay, so let's try it. So to be able to do it, technically what I need to do, you need to solve equation. Okay, so there's no shortcut. You need to solve this equation. So let's solve it. The left side looks correct, so I'm going to copy. You have 4k minus 5. However, on the right side, you need to remove the parentheses. So you're going to use the distribution property. You're going to multiply 2 times 2k, which will give you 4k, and 2 times negative 3, that will give you negative 6. And I copy the rest, which is plus 1. Again, then don't forget that you have also that plus 1. Okay, so now let's simplify. So I have 4k minus 5, it's equal 4k. And let's simplify. You have like terms. Negative 6 plus 1, this is just negative 5. So I'm going to stop here because I already see that the left side, it's exactly the same like right side. So I know that this is identity. So we know that. Okay, let's do example B. We have 2 times b minus 4 equal 2b minus 7. And again, we need to check if this is identity, conditional equation, or contradiction. So how are we going to know what we have? We need to solve it. So first, what we're going to do, apply the distribution property. We're going to multiply 2 times b, and we're going to multiply 2 by negative 4. Okay, so we have 2b, 2 times negative 4 minus 8, it's equal to b minus 7. So I definitely know that this is not identity because they're not the same expression on the left and on the right side. Okay, So let's try to solve for b. And we didn't do too many examples like this. So when you have variables on both sides, I want to move this to b to the left side. Okay, so since this is positive to b, I'm going to subtract to b from both sides. So all the time when you're moving the expressions or numbers to the other side of the equation, you're always using the opposite of what you see. Because on the right side, 2b minus 2b, it's 0. Okay? Okay. So what we only have negative 7 on the right side. And look what happened here. We have 2b minus 2b. This is also 0. So we end up with negative 8 equal negative 7. This is definitely not true. This is false statement. So when you have a false statement, okay, you have contradiction. So this is contradiction. And one more. This is the last one. Example C. We have 3x plus 7 equal 2x minus 5. So what we need to do, we need to solve for x. We're going to solve for x by bringing x's to the left side. So I'm going to move that 2x to the left side. Since it's positive 2x, the opposite of positive 2x, it's negative 2x. So I'm subtracting 2x from both sides of the equation. Okay. So on the right side, we only have negative 5. And we have 3x minus 2x, which is 1x plus 7. And now just solve for x. You see positive 7 on the left side. You want to move it to the right side. Since it's positive 7, use the opposite, which is negative 7. We're subtracting 7 from both sides. So that will give you x equal negative 5 minus 7, which is negative 12. Okay. When you solve an equation, you end up with a solution. You know that you have conditional equation. So this is conditional equation. Conditional equation means that our original equation, which is 3x plus 7 equal 2x minus 5, it's only true for x equal negative 12. Okay, guys. So we done with 10.2. I'm going to stop the video. Let me just fix it because originally I said that I was recording 2 videos, but I think that 2 videos, 2 sections in one video will be way too much. Okay, so let me just, okay. I will change that. I will change the name. So we're just going to, this video just records section 10.2. 10.3 will be in the next video. Okay, so thank you so much for watching and you will see the new video soon.